traveling at a speed of over about 10 miles per second, 24/7, 52 weeks a year. It has crossed this 4 billion mile ocean of space to the very frontier of our solar system. You see here in this image behind me the trajectory of our flight out into that disk of material we call the Kuiper Belt. The Kuiper Belt is a scientific wonderland that can teach us about the origin of our solar system and the planets in it. The first objective of the New Horizons mission was to explore Pluto and its system of moons, and we did that spectacularly in the summer of 2015. And after revolutionizing our knowledge, not just about Pluto and its moons, but also about dwarf planets in general, we went on, now in an extended mission, where we're going out into the Kuiper Belt almost twice as far as Pluto, ultimately. We've traveled another 1 billion miles in that time since the summer of 2015 to intercept this small body we call Ultima Thule, this Kuiper Belt object. And it is history-making, what we're doing. As we've said a couple of times, this is the most distant object ever explored. But it is, in addition, because of the cold temperatures out there, the most primitive object ever explored, and therefore probably the best time capsule we've ever had for understanding the birth of our solar system and the planets in it. Because the target is very small, the flyby is going to be very brief. The lead up to Pluto was more than 10 weeks long. We were only able to resolve Ultima for the first time from about 1 million miles away yesterday in an image that John Spencer will be showing you. This is also a much more challenging flyby than the flyby of Pluto, and it's taking place at an auspicious time on New Year's Eve and New Year's Day 2019. The reasons that this flyby is tougher are many. We're farther from the Earth, and so the communications times are much longer. We're farther from the sun, and so the lighting levels are lower, making it more difficult for our cameras and spectrometers to operate. In addition to that, we don't really know the environment around Ultima as well as we did know the environment around Pluto. And so we're taking some risks. Also, its orbit is not perfectly known, and making the intercept is tough. And finally, because the spacecraft is older, its power generator that's on board produces less wattage, so we have to manage our power much more carefully. All of these things add up to a much tougher, much more challenging flyby than what we had to do at Pluto, and I can't promise you success. We are straining at the capabilities of this spacecraft, and by tomorrow we'll know how we did, so stay tuned. There are no second chances for New Horizons. And I want to just close by saying, you know, the reason that New Horizons has been successful in its flight so far is because of the New Horizons team, an amazingly talented team of men and women, engineers, scientists, technicians, flight controllers, each of whom has been dedicated to this project and really poured their careers and their life, for that matter, into it. And there are many stories of individual contributions that made this project possible. There are many teams. We are a team of teams. But I want to point out one particular challenge and one particular person today, because we would not be here if it were not for him. You know, New Horizons is the first spacecraft to launch on a mission when it didn't have a target. We only discovered Ultima Thule in 2014 using the Hubble Space Telescope. And the man who's responsible for that discovery is our co-investigator, Dr. Mark Bowie of the Southwest Research Institute. And not only did Mark discover Ultima, he also made it possible for us to intercept it by developing state-of-the-art techniques to perfect our knowledge of its orbit well enough to hunt it down in the darkness of the Kuiper Belt from a distance of 1 billion miles away. Give him another round of applause. That's why you're here. Thank you, Mark. Okay, and with that, I'm going to turn it over to our project manager, Helene Winters.
Thank you, Alan. Okay, I'll update you on our flyby plans. Okay, our payload is comprised of 7 science instruments. 3 of them are cameras, and we have the REX instrument, which uses our own RF antenna. And we also have 3 instruments to to better learn about the particles. So the LORRI camera is the first device, the first instrument that we were able to use to see Ultima Thule. It's our long distance and ranging camera. We were first able to see Ultima Thule with it on August 16th of this year. And since then, we've been taking images, and it's gotten closer and closer, and we've been able to image it better and better. Initially, we had to use long exposure times and do what we call co-adding, take multiple pictures and layer them over each other so to see it in the sky. At this point, we don't need to do that. We don't need to co-add to see it. We can see it with the LORRI camera by itself. If you look at this crowded star field, it would be very hard to detect Ultima Thule in it. And Mark Bowie had used a technique similar to what Clyde Tombaugh had used to find Ultima, taking pictures, multiple pictures over a period of time and seeing it move in the night sky. Now here is where it actually is, where Ultima Thule actually is in this sky, in the region of Sagittarius. At the top part of the oval that you see, the ellipse that you see, you'll see it appear when I show you this film clip. This is layered multiple images taken over the last month. And you can see it growing out of the center. So those are the pictures we've taken, like I said, over the last month with the LORRI camera. And now we're able to see it just now with the Ralph camera as well. So here's our timeline of flyby activities. We have, you can see in August where we first were able to image Ultima Thule with LORRI. We've been taking what we call optical navigation images, or OpNavs, with LORRI since then. And still, we're taking them OpNavs daily to better, we were taking them to, at that point to better understand its position. And then we did a series of maneuvers, trajectory correction maneuvers, to adjust our spacecraft's trajectory to better, more precisely target that close flyby at 3,500 kilometers or 2,200 miles from the center of Ultima Thule. As we got a little closer in the November time frame, we also made hazard observations. We took more pictures to look very closely for any potential hazards, perhaps moons or rings that might obstruct our path along the trajectory. We did not detect any, so we were able to fly our optimal trajectory, 3,500 kilometers. Had we found any obstructions, we could have flown by at 10,000 kilometers. We would have had a divert maneuver to fly to that farther distance. But we were able to fly by at the optimal distance for the science folks. And you can see at the vertical line is where we have our closest approach. And then we're downloading data already, downlinking data from the spacecraft. And we'll continue to downlink data. We'll get just a bit before we go into solar conjunction from the 4th through the 9th of January, where the Earth will be on the far side of the sun from the spacecraft, so that would interrupt our communications with the spacecraft. So during that time, we won't be able to get much data down. And then we'll resume our downlink beyond that, and it'll continue for a period of about 20 months. Okay, here we have an expansion of the inner part of that timeline. We recently were able to make timing updates based on those OpNavs as Ultima Thule gets closer and closer. We were able to tweak the information that we store on board the spacecraft about the location of our target body. So we were able to adjust the timing by 2 seconds to better image it, and adjust our pointing so our images more accurately capture as centered as we can be on Ultima Thule. And then you can see closest approach at the circled green diamond. So the blue diamonds before closest approach on the timeline are what we call our fail-safe images, where we've taken images on the approach in case anything should happen at flyby to the spacecraft where we wouldn't be able to get the data down. So we have those on the ground, and we'll be showing those. Basically, the fail-safe image will show, the second fail-safe image will show at our press conference tomorrow. and on the 1st at 11:30, and then each day for the next couple days, then we'll have press conferences at 2 to show the images that we've collected from the day before. And then beyond closest approach, you see where we have our essentially our quick look images, our first opportunity to look at the flyby images. They won't be at full resolution that we'll see, but John will talk to you more about that, the images that we'll see later as we get closer and are able to downlink those.
Okay, thanks. Navigation is about driving the bus to the destination within the requirement set forth by the scientist. You see on this image a close-up view or our flyby trajectory at closest approach, where we're going to fly due north of Ultima Thule, about 2,200 miles away. And the goal of the navigation team is to determine the relative positioning between the spacecraft and its target. And we want to put this within roughly a 40 square miles box and get the timing within 80 seconds or so. So considering that we are 1 billion miles beyond Pluto, this is quite an achievement and a challenge for us. And as my colleagues mentioned, we are using the LORI imager to get our relative positioning. But the first thing we need to really capture or understand is the position of our spacecraft in the solar system. So we achieve this by using the Deep Space Network, which is a series of antennae that NASA has that are strategically positioned around the globe in California, Spain, and Australia that are designed to basically see the NASA spacecraft all the time. And then we are basically using these antennas not only for uplinking comments to the spacecraft or downlinking images, but also to get our velocity and ranging information for the spacecraft. Then we need to worry about our targets. So as it was mentioned before, and thanks to Mark Bowie's work, we have used the Hubble imagery to get an initial look of where Ultima's orbit were. Now, the missing information with this was the depth of Ultima Thule as seen from the sun or Earth. And that's only when we combine the LORI imagery on board that we acquired starting in August up until very recently with the Hubble imagery that we can really get the positioning of Ultima. So as we do this over the time, we need to allow ourselves to adjust our trajectory. So what we do is we design course correction maneuvers, and we performed the last one on December 18th. And the missing piece, the final piece, was to acquire the images up to the 30th of December to basically get us the final relative positioning so we could uplink that, the final pointing update to the onboard the spacecraft. And we did that. We designed this solution 2 nights ago. I wanted to go back to the optical imagery that we did, that Elaine presented, and maybe give a little more detail on the challenges. It's what you see on the left is the raw imagery that we are working with, and there's a lot of stars in there. The resolution is not the best, so it's a real challenge to really pick out where Ultima is. So what we do is we do a series of processing. One piece is co-adding, like Elaine mentioned, and we also are refining the resolution on the imagery since we have many images to work with. And lastly, we are subtracting the stars to clean it up, and that's the image you see or the video you see on the right. So I want to end up with a global view of our trajectory work since launch, maybe focusing after the Pluto flyby in 2015. We did a series of 6 course correction maneuvers. The first one was 100 days after Pluto. where the maneuver was fairly large, and we had to break it up into 4 pieces to make sure that the spacecraft could execute it. And then the last one, like I said, was on December 14. And I compared this to essentially trying to hit a requirement size of the size of a golf ball if you were to start from the West Coast and try to hit your bullseye on the East Coast. So with that, I think everybody's excited to try to see some science imagery. I'll turn it over to.
Yes, so I'm going to tell you a little bit about what we hope to accomplish with this flyby. We have a series of science objectives. One of the prime ones is to map the geology of Ultima, whatever craters it might have on its surface, whatever fractures, other topography, anything that will give us clues as to how its surface was formed. We want to map the composition and color of the surface. The color itself gives us information on the composition. And so we're looking for ices on the surface, other things that we probably haven't imagined yet. A particular mystery is we want to know why Ultima and objects like it in the Kuiper Belt, there are hundreds of thousands of objects we think like Ultima out there, tend to be dark and red. We think they're mostly made of ice, but their surfaces don't look icy, they look dark and red. So we're hoping to delve into that mystery. We're also looking for satellites and rings, and we can search for moons that are very small, less than a couple of 100 feet across. We haven't found any moons yet, and this image shows a view from a couple of weeks ago where we were looking in the area around Ultima to see if there was anything hazardous. And we didn't see any hazards, we didn't see any moons, any rings, but we can look with much more sensitivity now because we're so much closer, and who knows what we might find. And after we fly past, we'll be looking back towards the sun and looking for any rings that might show up with that illumination. And rings around a tiny object like this may sound crazy, but we actually know of one other Kuiper Belt object and another object originally from the Kuiper Belt that do have rings. And so anything is possible out there in this very unknown region. We're also looking for any gas or dust that's coming off Ultima. We don't expect to see this at all, but comets do show this kind of behavior, and this is a spectacular image of the comet CG taken by the Rosetta spacecraft, showing these spectacular plumes of dust and gas streaming off from it as it's heated by the sun. Because Ultima has been in the same orbit for 4 billion years, any gas that would have evaporated has probably evaporated long ago. But this is unknown exploration. Anything is possible. And so we're doing our best to look for even these rather surprising and unusual possibilities with the observations we're taking. So we're making ultraviolet instruments, and we're taking images, backlit images, to look for this kind of thing. We are starting to learn about the shape of it, and I'll show you in a minute our first clues on that, but we don't know very much up to this point. We have the shadow of Ultima as seen from its passing in front of a star in an effort that was actually led by Mark Bowie again, to get some idea of its shape. And we see those 2 red circles give some approximation to how we might explain the shadow that we saw from those observations. And that might mean it's 2 objects that are orbiting around each other. And as we've got closer, we haven't seen evidence for that. But we still have to get the really close-up images to be sure. Or it could be a single object that is elongated. It could be a couple of objects that are stuck together and are resting on each other, kind of like the artwork you've been seeing here. And so we'll find out soon enough, and I'll show you some clues already that we have. We don't know if the surface is going to be covered in craters, which we might expect, but there's some recent ideas that, no, we may not actually see craters here because things don't run into each other very often in the Kuiper Belt. We might see evidence, like again on Comet CG in the middle there, of sublimation where gas and dust has left the surface and left holes behind. Or we might see something really crazy. This is, on the right is a picture of Saturn's moon Helene, no relation to our project manager, which has this crazy eroded surface. And so anything is possible out there when you're exploring a new class of world you've never seen before. And so the images that we're getting in the next couple of days, and we'll be hopefully showing to you coming up are our first images that show any kind of detail we got down last night. I'm going to show you those in a moment, but don't get too excited. Then tomorrow we'll be showing images that show more pixels, about 6 pixels across, will give us some idea of the shape. And then if everything goes smoothly on January the 2nd and the 3rd, we will have more detailed images where we'll begin to see features on the surface. What you're seeing here are simulations pretending we were looking at Mars's moon Phobos, which probably looks nothing like Ultima, but it gives us something of about the right size and shape that we can use as a substitute here. And so that gives some idea of the kind of detail we're hoping to see in the next few days. And now I can show you the real version of that image on the left-hand side, which is what came down last night and has already got us very intrigued. And here we go. So the image on the left is the images as they came down from the spacecraft. It's a blob, only a couple of pixels across. But you can see just from that blob that it's an elongated blob. It's not round. And so we're already seeing that there's some interesting shape to this thing. And this is somewhat consistent with that shadow that we saw from the observations from the Earth. So that's not too surprising. But now this is just the first glimpse of what's going to get rapidly better from here on. When we sharpen up that image, we see that indeed it's quite an elongated object, maybe twice as long in one direction as it is in the other direction. So this is just our first taste. We're going to learn more very, very soon, and we just can't wait. So thank you.
So thank you guys for that overview, too. I never saw a team get so much out of a dot, right? We've been doing for so long. Before we move on to the questions, though, Alan, I believe you had something else to share.
Yeah, I do. Thank you, Mike. As you might imagine, I'm getting a little extra email this week. Overnight last night, I received one email that I want to read in its entirety. It's from Dr. Thomas Zurbuchen, my colleague and friend who directs NASA's entire science enterprise and runs the Science Mission Directorate. So let me read that to you. It's 3 paragraphs. He said, Alan, as you know, we are on government shutdown and I am unable to contribute to this historic event like I intended to. I will be sure to be there tonight, though, with my family, and here's why. I think that it is fitting that this flyby of Ultima Thule is at the interface of the 60th anniversary of Explorer 1 in 2018 and the 50th anniversary of Apollo 11 in 2019. To me, this milestone of New Horizons is full of everything NASA and NASA science is all about. It is about boundless aspiration and hope that are the inception of exploration. It is about innovation and persistence and perseverance to actually create the success by an amazing team that transcends what is reasonably expected or even what seems initially possible. And then it is about surprise and transformative learning that has been at the heart of NASA and NASA science and exploration during the past 60 years. The Ultima Thule flyby has all of these. For all of those reasons, I wish you and your team the best of luck. We at NASA Science are incredibly proud of you and your team, both the science team and the engineering team, and we can't wait for the surprises that will be uncovered during the next hours and days. Go New Horizons, go exploration forever. Thank you. Thank you, Thomas. Now I hope that, I just hope that Thomas doesn't mind me reading his email to the world.
Thanks. So with that, we will go to questions for the media assembled here. I know a lot of people are following online too. So if you are following along with this mission on social media, we are on nasa.gov and we are also on pluto.jhuapl.edu with the hashtags Ultima Thule, Ultima Flyby, and Ask New Horizons. We'll take questions first here in the audience. I know if the media, if you have a question, we have people on the aisles that will hand you the microphone. If you could identify yourself before you ask your question, and then we'll move on to the next ones.
Hello, Marcia Dunn, Associated Press for Dr. Stern. You've referred to this as auspicious beginning to the new year. Could you sort of elaborate on how you see this fitting into the exploration history of the world, most significantly 50 years after astronauts, flew to the moon and almost ready to, come up on the Apollo 11 anniversary? How it all fits together in your mind?
Sure. Thank you for the question. One of the things that distinguishes human beings from all the other species on Earth is that we are so inquisitive and that we are naturally explorers. And I think space exploration really typifies that attribute of human beings. It's amazing to think that we as a species are interested in the rest of the universe and that we actually go out and explore it. And I'm very proud of our time and all the countries on Earth that are becoming involved in this historic enterprise. 50 years ago, the first humans walked on another world, the moon, as a result of NASA. And NASA was actually the first space agency to reach every planet in the solar system, from the closest planets, Venus and Mars, to the farthest, Pluto. And now we're out exploring even farther. And you know, we put all the data in an archive where anybody in the world can see it. We don't keep it to ourselves, we share it. And I think that the kinds of things that NASA's doing are the envy of the world. And they go down in history, and they really set the United States apart as a leader. And I'm very grateful for all that.
Hi, Bill Harwood, CBS for Alan. What can you learn, some specifics about what can you learn about studying a cold classical KBO that you can't reverse engineer from looking at an asteroid or a comet closer into the sun? In other words, what is it that's frozen in time that's going to tell you so much about the formation of the solar system?
Yeah, I'll take a cut at that, and I think maybe John Spencer might also add a little bit. But there are really two attributes of Ultima Thule that make it so scientifically valuable for us. First, because it's so far from the sun, and the sunlight is so weak out there, temperatures are down near absolute zero. And as a result of that, chemical reactions are essentially frozen. So the object is in such a deep freeze that it's perfectly preserved from its original formation. And when you combine that deep freeze with the fact that Ultima is a small body, only tens of kilometers across, and can't have a strong geologic engine, like Pluto, for example, which is also cold, but which you can see the activity on its surface and in its atmosphere, Ultima doesn't have the ability to evolve that way. So everything that we're going to learn about Ultima, from its composition to its geology to how it was originally assembled, whether it has satellites and atmosphere or those kinds of things, are going to teach us about the original formation conditions of objects in the solar system that all the other things that we've gone out and orbited, flown by, landed on can't tell us, because they're either large and they evolve, or they're warm and they've evolved for that reason. Ultima is completely unique. John?
Yeah, just add a little bit that it's part of this structure, as you mentioned, called the cold classical Kuiper belt, which is a remarkable structure. We have small bodies scattered through the solar system. We have the asteroid belt, where things have been really stirred up, particularly by Jupiter. They've crashed into each other, broken into smaller pieces. Everything is very mixed up and not in its pristine shape there. And we have comets, which, as Alan said, have been altered a lot by the sun's light. But out there, we have this belt of objects that are in almost circular orbits, that are flat orbits, the same plane as the planets. They have to have just, nothing has happened to these things since they formed. It's the only small population in the solar system, the only population of anything that we know of in the solar system, where virtually nothing has happened in the last 4 billion years. And so it's a very special region that we're very excited to explore.
Next question here.
Hi, I'm Ken Chang, New York Times. I was just wondering how everyone's feeling now versus 3 years ago at Pluto. Are you more relaxed and confident because you've done it at Pluto, or is it still tense because of all the challenges that Alan was talking about?
Who wants to take a crack at that? I can tell you that we're very confident in the spacecraft, and we're very confident in the plan that we have for the exploration of Ultima. But I'd be kidding you if I didn't tell you that we're also on pins and needles to see how this turns out. We only get one shot at it. It's nothing like this has ever been done before. And with any enterprise like this, there comes risk. Fortunately, the rewards are worth the risk, but there is risk to the spacecraft and to the science that we're trying to do. And I think by tomorrow morning, we'll know how it all turned out, so stay tuned.
Hi, I'm Alan Boyle with GeekWire. Based on that first image, and perhaps you've had a chance, I don't know, to look at the fail-safe imagery, I realize it's too late to make any sort of change in the flyby maneuver, but is there anything that this image tells you about what you'll be looking at? Does this kind of definitively say that it's an elongated object rather than two or more smushed together objects? What does this tell you?
John?
Yes. I think it's a little early to say. We know it's not round. We can say that with confidence. But yes, this is not inconsistent with it being two smushed together objects like the artwork that we've been showing, which we just don't have the detail to see yet. It could well look like this right now, but we will know very soon.
Alan, hang on to your hat. I have to say, I said to the science team last night when this image first came in, I'd never seen so many people so excited about 2 pixels.
But we've had only 1 pixel for so long.
Okay, I think we have some questions over the phone, too, so let's take one of those.
We have a question from Keith Cowing, Nathalach. You are unmuted.
I actually had 2 questions to ask, but after hearing the email from Thomas, I'm going to ask the second one for Dr. Stern. You're going to have a spacecraft that is filled with fuel and obviously working rather well. Even if you're going after another Kuiper Belt object, you're going to have a lot of capability left over. Has any, and this is a way out question, but has anybody given any planning thought to a recreation of the pale blue dot image, albeit with a far more capable spacecraft and a little more time to plan it?
Yeah, so what the question is asking is whether New Horizons can reproduce the solar system portrait that Voyager took almost 30 years ago. In fact, we think we have the capability to do that, but it comes with some significant risk to the cameras because the planets are so close to the sun in angular terms, as seen from New Horizons. Taking that image runs the risk of burning the cameras out and actually permanently losing the cameras. So we don't want to do that until we're finished with all the flybys that we can possibly get out of this mission. And we do have an ambition of looking for another target after Ultima. So any image like that, which we very much want to take, will be years in the future.
Okay, I think we have another phone call. So I think we have another question over the phone.
Yeah, we have a question from Alexandra Whitby from Nature. Not there.
Okay, we can wait for that one. If we have any more questions here in the audience, let's go back to the audience first, and then we'll wait to see if we have the phone straightened out.
Hi, thank you very much. Up close. First, congratulations and good luck, all of you. Based on that first image and what you said about the no geologic engine, can you talk a little bit more about what you might expect or speculate on the surface of craters versus it being smooth or being something completely different? What are you thinking to this day? Thanks.
Well, I don't make predictions. I've seen too many of those go down in flames, and anything that I said today will almost certainly be wrong tomorrow. But I can tell you what we're interested in, and I'll give you one particular example for myself. We want to understand how objects like Ultima were assembled. There are 2 basic theories for how the building blocks of planets were assembled. In one case, you put objects together piece by piece, and in the other theory, they're built by sort of a hailstorm of pebbles and boulders and other kinds of particles. And depending upon whether we see a heterogeneous object or a monolithic object, we might be able to find out which of those theories is correct. John?
Yeah, I maybe say a bit more about the issue of cratering. Most small objects in the solar system have a lot of craters because they're old, they're not having geological processes that are erasing those craters, so they just accumulate scars from other things running into them over the age of the solar system. But a paper just came out that looked very carefully at how often Kuiper Belt objects run into each other. And it's not very often. There are hundreds of thousands of them, but they're spread over an enormous region of space, and they're all kind of cruising along in the same speed, in the same direction, you know, kind of like on a freeway. And like on a freeway, fortunately, collisions don't happen very often. And so we may not see many craters at all. That would be a really interesting result. And if it's true, we might learn about the surface before it got covered in craters that would have been erased on other objects. So that's just an example of how little we know right now, and the kind of ideas that are out there as to what we might find. And yeah, we'll know very soon.
Okay. Let's do another one in here, and then we'll see if the phone line is open.
Stephen Young with Astronomy Now. Alan kind of hinted that the science team was excited by these 2 pixels, but I'm wondering if you could, either you, Alan, or John, say whether the science team has moved in any different directions with their conversations, speculation, interpretation, since they've seen this image?
John?
Oh, there's a lot of chatter in the science team room, and we're doing everything we can with so little information. It's kind of crazy because we're just so excited by this. But we know anything we say is going to be wrong tomorrow. And so ask us tomorrow, and then we may put you off another day. But we'll have much better images in a couple of days and these will be irrelevant at that point. So we're having a lot of interesting conversations, but we'll probably be wrong about them. So we'll wait until we know more.
Well, I'll just add one thing, and that is, you know, after 3.5 years of planning for this, it's becoming very real all of a sudden.
Okay. We can stay here for a couple more questions, too, if we have them.
Hi, I'm Stephen Clark from Spaceflight Now. I was wondering, in the last day, have you been able to sort out anything about the rotation rate of this object? I know you've been searching for that for weeks, and you haven't been able to find anything. Any news there?
Right. So as background, by taking repeated images over time, we can see how the brightness of Kuiper Belt objects vary. And we've been doing this for years now as we cross the Kuiper Belt and studying the rotation periods of a whole suite of different Kuiper Belt objects. The only one that hasn't yielded a clear light curve is Ultima. What's up with Ultima? We don't know. And here we are now just, 10 hours from a flyby, and we still don't have a reliable light curve. We will find out why that is in the next 24 hours.
There's another one in here.
Thank you. Tarek Malik with Space.com, and I think this question is for Helene. You mentioned in your talk that it'll take something like 20-odd months to get all of the data from this encounter back, and I know there was a similar kind of a year-long or plus for Pluto, and I'm wondering kind of how that data is prioritized. Why does it take so long to kind of get so much data from what is essentially just a few hours of glimpsing before you shoot on by like a bullet? Thanks.
Sure, thanks for the question. So the data downlink, we're not just taking data coming down from the flyby, but we're also making observations of other distant Kuiper Belt objects along our trajectory, or that are not along our trajectory, that are from a distance. So we have to get that data down as well. And the prioritization for the data downlink comes from the science team led by Alan. They let us know what's most significant, what they'd like to see first. And also we have housekeeping data that lets us know if, ensures us that confirms that the spacecraft and its subsystems are healthy and flying safely.
I'd like to add, I am in awe that we can even do this. The technology that's involved is incredible. The spacecraft has a 15-watt transmitter on it. 15 watts. It's a quarter of a light bulb. Not 15 kilowatts like a radio station, 15 watts, and we're receiving it from 4 billion miles away, these incredibly weak signals. And the fact that we can send data back at 1,000 bits per second, given those challenges, is unbelievable. And when you combine that with these advanced scientific instruments that take data like a fire hose and put them into flash memory on board the two computers, where they're stored, we completely fill those memories to the extent that the engineers will let us, and then trickle it back at that 1,000 bits per second. And remember, we have to share the Deep Space Network with all the other missions that NASA's flying across the solar system. So the combination of all those things together spells out 20 months.
Okay, so now we have a phone question.
Yeah, hi, this is Alex with Nature. Can you hear me?
We got it, Alex, yep.
Great, thanks. I wanted to ask John to talk just a little bit more about shape, this elongation that you're seeing. How is that consistent with the results you were seeing from the occultation studies earlier this year? And what, if anything, does it say about if this is a multiple object kind of squished together, whether you might have 2 or 3 objects smushed together?
Well, yeah, we've been having fun playing games, taking this fuzzy blob that we're seeing in these images and comparing it, sort of superimposing it on this intriguing shadow outline that we got from the occultations last year. And it fits pretty well. There's a lot of leeway in that occultation shadow because we only have a few points on it. And there's also a lot of leeway in this fuzzy blob, obviously, because it's so little information. And the hints that we had of 2 bodies in the occultation, I think it's safe to say we still are consistent with that. We'll just have to wait just a few more hours to confirm that. But I'll actually point out one intriguing thing, and I need to borrow Fred's pen for this. So as Alan mentioned, we haven't seen a light curve. And if it's elongated, as it appears to be, it wouldn't be as elongated as this pen, but if it's spinning like this, sometimes you'd be seeing it broadside on, and sometimes you'd be seeing it end on, and you should see a lot of variation in brightness, and we just are not seeing that. So our current best theory is that it's actually spinning like this. And so though it's elongated and it's spinning, we're always seeing the same side. And so that's our current best theory, and again, that might be proved wrong tomorrow.
Okay, we got one more question here in the audience.
Kelly BD Sky and Telescope, hi. So given that your hope is that this is the most pristine possible surface, which of the experiments offer you the best chance to actually determine the composition of what you're seeing, especially if it turns out to be dark and red? Do you have some hope of, gases being liberated, whatever, Pepsi, I don't know.
John, you want to take it? Or you want to take it?
Okay. I'm really interested in the color pictures that we're going to get because the Kuiper belt is really intriguing in its colors. We have a variety of objects that are very bright, like Pluto. We have smaller objects that are kind of grayish colored, and we have other objects that are red or brownish in color. And we don't understand at all why there's this variation. And the cold classicals, this very flat circular belt of objects that that Ultima is part of, all seem to be red. Other parts of the Kuiper belt have gray objects and red objects, and all these cold classicals are red. And that's really intriguing. It's a really important clue as to what's happening out there. And so by looking at the one object close up and seeing how maybe color varies across its surface, maybe it's brown, but it has gray craters, or who knows what. We might get some clues to what this big mystery is about the colors from that. But again, it's all speculation at this point. And it could be that the biggest clue is going to come from the infrared spectra that give us the surface composition. It could be that the best clues are going to come from the close-up images from our telephoto camera that will show us the craters, and the morphology tell us something about the history of its surface. Well, we just don't know yet, and that's what makes this so fun.
Because we had a little hiccup with the phones, I'm going to go one more time because I understand we have another call in the queue. So one more question from the phones. Okay, this is Keith from NASA Watch. Go ahead.
Yeah, Keith County, NASA Watch once again. Here's my other question. This is a bit like, with the speeds that you're talking about here, this is sort of like Star Wars TIE fighters flying over the Death Star. And I was just wondering, given that it's the proverbial bullet going after a bullet, is there any interest, or has there been any participation on the part of the Department of Defense? I know APO has some contracts with DOD, and there are precedents like the Clementine mission, which did seek to track things, and oh, by the way, they used the moon to practice with. So again, the question is there any DOD involvement with this? If there hasn't been, will there be?
Let me give you a very precise answer, no.
All right, well, thank you for those questions there. I'll give you guys the opportunity. Any concluding thoughts from the panel?
Great job.
All right, we're good.
Really nice, Fred.
All right, so thank you for joining us. I will advise you, like our spacecraft, our schedule moves quickly. So keep following us online at nasa.gov and at pluto.jhuapl.edu. Follow us on social media with the hashtags Ultima Thule, Ultima Flyby, Ask NASA, and Ask New Horizons. We have several other opportunities and events coming up. This evening we are going to have a Ask the New Horizons team online. Plenty of activities tonight of speaking and team members giving overviews and background on the mission itself. And then, wait, just after midnight, we'll have the debut of a song, New Horizons, from Brian May, contributing scientist, New Horizons science team member, astrophysicist, and oh yeah, guitarist for the band Queen. And then at 12:33 a.m., we'll mark the moment where New Horizons will be flying by Ultima Thule 4 billion miles from home. So thank you for joining us. Keep flying with us and keep exploring with New Horizons.